Hi everybody. So this is a short video about part of 4.3. You should have already watched the two videos that describe what a logarithm is and then how to evaluate a logarithm. Okay, so we're going to talk about specifically solving exponential equations using logarithms. Okay, so let's talk about the plan for how you do this. Okay, so the first step is to isolate the exponential. Okay, so remember what makes something an exponential is that you have a numerical base, okay, and then you have a variable in the exponent, okay? Then the next thing we want to do is we're going to rewrite in log form. Okay, so this is something that you should have seen in part 1, rewriting something in log form, rewriting something in exponential form. Okay, so we're going to take an exponential expression and we're going to rewrite it in logarithmic form. Okay, then the last thing we're going to do is finish solving for x. Okay, all right, so let's go ahead and look at an example. Okay, oh, the other thing is before, when we were solving exponential equations in the last video, right, we're using the method of equating exponents, okay? So in this example, we're going to be looking at times that you wouldn't be able to use that method, or times where maybe that method would be too difficult, okay? All right, but before we do that, we are going to look at examples that are pretty easy. So I understand that you could solve these using that same method that we talked about last time, equating exponents, okay? So we're just going to use these easy examples to show you how you're going to do this, okay? So the first thing we want to do is isolate this exponential part, the 5 to the 2x part. Got a little cat face in there, okay? And we're going to do that by dividing away this 5, okay? So we're going to divide both sides by 5. Okay. All right. And then now is when you have to decide what method you're going to use. Okay. So you certainly could use equating exponents and you would write both of these as powers of 5. Okay. Or you could use the method that we're going to use now and use logarithms. Okay. All right. So we're going to use logarithms, okay, just so we can see how this method works. Okay. So we're going to change to logarithmic form. Okay. So remember, the base of the exponent becomes the base of the logarithm. Okay. 25 goes here. Okay. And the exponent is your answer. Okay. So now we need the stuff that was in part 2 of the video, which is evaluating logarithms. Okay. So remember, this is asking you what power of 5 is 25. Okay, so what power of 5 is 25? Well, 5 squared is 25. Okay, and then over here we still have 2x. Okay, and now we're going to divide both sides by 2. Okay, so just to recap the steps that we did, we isolated the logarithm, or isolated the exponential, changed to logarithmic form, we evaluated the log, okay, and then we solved for x. All right, let's look at another example like that. Okay, so again, we're going to start by isolating the exponential part. So we're going to divide both sides by 90. Okay, Now again, for this example, you certainly could use the equating exponents method, okay? But here we're going to demonstrate the method using logarithms, okay? So I'm going to change to logarithmic form. The base of the exponent becomes the base of the log, okay? And remember, the exponent is the answer, okay? Now I need to evaluate this. What power of 4 is 2? Okay, what power of 4 is 2? Well, we know that the square root of 4 is 2, right? And remember, the square root is the same as the 1/2 power. Okay, so that would tell me that this whole value is going to be 1/2. Okay, and there's no additional steps to solve for x because x was already isolated on the right side. Okay, so again, the same steps. Isolate the exponential, change to logarithmic form, and evaluate the log. Okay, let's look at one more example like this before we move to some examples where we wouldn't be able to use the other method. Okay, we're going to start the same way. We're going to isolate the exponential part. So I'm going to add 4 to both sides. Okay, and then I'm going to divide both sides by 5. Okay, now again, this is the last example where you could use equating exponents. You could write this as a power of 2, this is already a power of 2, and you could match the exponents. Okay, but we're going to use the log method. Okay, so we're going to change this to the log. The base of the exponent becomes the base of the log. Okay, and the exponent is the answer. Okay, all right. Now we're asking what power of 2 is 16? 2 to the 4th is 16. Okay, and our last step is to subtract 1 from both sides. Okay. All right. So let's look at some examples where you wouldn't be able to use the equating exponents method, right? Because most students agree equating exponents is a lot easier. So mostly you're not going to use this method if you could equate exponents. You're going to use this method if you wouldn't be able to. Okay. All right. Okay. So we're going to start the same way. We're going to isolate the exponential part. So the first thing I'm going to do is add 11.6 to both sides. Okay, and now I'm going to divide both sides by 2. Okay, now I have my exponential isolated. Okay, so now you can see in this example why you wouldn't be able to use equating exponents. Okay, this is a power of 10. How could you write 11.9 as a power of 10? Okay, it would be too hard. You wouldn't be able to do it in your head. Okay, so that's why we need the log method. Okay, so the base becomes the base of the log. Okay, and right, the exponent becomes the answer. Okay, now I want to point out one thing about notation. Okay, hopefully you saw this in the first and second video. When you have log base 10, that's called a common log. Okay, and you don't need to write the 10. Okay, So that's really just a notation thing, but I wanted to point that out. When you see log with no base, that means log base 10. Okay? And now are we able to do this by hand? We're not. Okay? So what we're going to do right now is we're just going to divide both sides by 1.4. Okay? I'm just going to write that I would divide it by 1.4. Okay? So this is my exact answer, okay, that I would get from solving this equation by hand. Now, if you want an approximate answer, okay, you could always pull out your calculator, okay, plug in log of 11.9. Okay, I'm going to put wavy equal to for approximate answer, okay, and you would get 0.768 as your approximate answer. Okay. All right, let's see another example where you need the log to solve. Okay, so I'm still going to try to isolate this expression. So the first thing I'm going to do is divide both sides by 80. Okay, and now I'm actually going to reduce my fraction. Okay, divide them both by 5 to get 13 over 16. Okay, now if I really want to isolate this, I have to subtract 1 from both sides. Okay, and I would make common denominators to do that. Okay, now the last thing I need to do to isolate this 10 to the negative 0.2x is to get rid of the negative sign. So I'm going to divide both sides by negative 1. Okay. All right, so all of those steps were just to isolate our exponential. Okay, now we're going to change to log form. Okay, log base 10 of 3 over 16 equals minus 0.2x. Okay, now again, we can't evaluate this by hand, so we're just going to leave it. And we're going to divide both sides by negative 0.2. Okay, here's my exact answer. Okay, and if I want an approximate answer, okay, I would enter this exactly this way into a calculator. And I would get x is approximately, oh, I actually don't have an answer for this. I'm sorry. I'll just put calculator. Okay. All right, let's look at one more example like this. Okay. So the first thing I'm going to do is try to isolate this exponential part, so I need to add 7 to both sides. Okay, now I have my exponential isolated, okay, so I'm going to change to log form. It's going to be log base 10 of 22.14, okay, and then the exponent is the answer. Okay, Again, you can't evaluate this by hand, so you should just leave it in this form, okay? The difference with this example is I have some other stuff I need to do to isolate x. So first I'm going to add 2 to both sides. Okay, and now I need to divide both sides by 1.15. Okay, and this is my exact answer. Okay, so I hope you guys can see the two different situations where you would need the equating exponents method. If you can use that method, I think it's really easy and it's pretty fast. But if that method won't work, okay, and the way you can tell is like here, you can't rewrite this and this in terms of the same base, then you're forced to use the logarithm to solve these equations. Okay? Stop on by the office hours if you have any questions, and I'll see you guys soon.